This ShowMe is about translating English phrases into variable expressions, a very important skill when it comes to solving real-world or word problems. To begin with, algebraic expressions are built using variables. A variable is a letter that stands for a number. By far, the most popular variable in all of algebra is x. But you'll also quite commonly see y and z. You'll also see p and q, r, t, u, v, and w. To a lesser extent, you'll also see letters from the beginning of the alphabet. You won't see I very often, and you won't see O very often, and you'll see S more often than I or O, but not terribly often. The reason is that I resembles 1 too much. O, of course, resembles 0 too much, and S, especially when I write it, has a strong resemblance at times to 5. We use variables to build variable expressions. A variable expression is a mathematical phrase that uses variables, numerals, and operation symbols. It's worth it here to recall your training in English. A phrase is not a sentence or a clause. Sentences and clauses have subjects and verbs. A phrase does not denote that anything is happening or that one thing happens to be like or to be another thing. A phrase is not a complete thought. It's part of a complete thought. A variable expression is not a complete thought. It's part of a complete thought. It's the part that represents a particular quantity using a variable. Let's take a look at these 5 expressions here on the left and decide whether they are numerical expressions or variable expressions. 5 minus 5 has no variables in it at all. It's a numerical expression. C minus 5 has a variable. The variable is C. It is standing in for a number. C minus 5 is a variable expression. 8 divided by x has a variable. X is standing in for a number. 8 over x is a variable expression. 100 times 6 has no variables. It is a numerical expression. D plus 43 minus 9 has a variable. D standing in for a number. D plus 43 minus 9 is a variable expression. Here are some words that imply various operations when we translate from English to algebra. If you see words that include total, it's safe to draw the conclusion that you're going to be doing some addition. In the same way, if you see that one number is so much more than another, that will probably be an addition. If you see that one number is going to be increased by a certain amount, that is going to be an addition. Subtraction is very challenging, probably the biggest challenge my students face in translating from English to algebra. If we're going to take a difference of two numbers, that usually means that we're going to subtract the smaller number from the larger number, and the numbers may not be in that order. So be very attentive to the order the numbers appear and the order that it seems to be appropriate for the subtraction when you do a translation. English is not great for subtraction. In the same way, fewer than and less than, if you see that one number is to be so much fewer than another, say 5 fewer than 7, that usually translates as 7 minus 5. The numbers are spoken in English in one order and written in algebra in the other. Just be attentive to the meaning of what you are reading. You must comprehend what you're reading well, or the translation will not go well. The same thing is true of less than. If you see that one number is to be 3 less than another, that 3 probably will be written in algebra after the subtraction sign, even though it was written first in English. The one version of subtraction in English that does make sense in terms of the order of the numbers is decreased by. If you see that one number is to be decreased by 6, that probably means that you're to take that number and subtract 6. So be very careful. For the first 3 words representing subtraction, the order is a concern. It may well be that the order the numbers appear in English will have to be changed when you translate into algebra. On this frame we have words that imply multiplication or division. Product and times both imply multiplication. In algebra, the x symbol is deprecated. We don't like to use it because x also is a very common variable in algebra. We prefer to use the dot, or sometimes simply to write the numbers next to each other, sometimes with one of the numbers in parentheses. Each, per, and quotient all can refer to division. Per and quotient usually do. Each is a bit tricky. If you see the word each in the context wherein we're determining how much is being distributed to a group of people, and each one receives a certain amount, that's actually multiplication. But if we are to determine how many people in a group are to receive each the same out of a given amount of stuff, that would be division. So be careful with each. You must check the context of what you are reading in English to determine which algebraic operation you want to use when you translate. Let's consider these 5 examples. How would we translate 9 more than a number? Well, 9 translates as the number 9. From the previous screen, actually 2 screens ago, we know that more than translates as addition. And a number means a number that we do not know. We'll have to pick a letter to represent it. Let's choose A. So 9 more than a number could be 9 plus A. For our second example, we're talking about 4 less than a number. This is one of those times that I warned you about, where the word that comes first actually translates to a number that comes last. If we have 4 less than a number, we do not want to start with 4 and subtract the number. That actually would be a number less than 4. We want a 4 less than a number, so the starting point is the number itself. We don't know what the number is. We'll call it B. Less than implies subtraction, and then 4 actually belongs at the end. We're taking it from the unknown number. So 4 less than a number translates B minus 4. Please notice that the words appear in the reverse order from the things I used to represent them in the algebraic expression. A number times 3. A number could be C. Times would be a dot. And 3 would be 3. A number divided by 12 is an unknown number D divided by 12. This fifth example is very important. Let's read it carefully first. 5 times the quantity 4 plus a number. 5 times the quantity. What quantity? Now the words that come next are the quantity. The quantity we're talking about is 4 plus a number. Not the quantity 4, but 4 added to the number. That quantity has to be calculated first. The symbol we use to make sure that an addition, 4 plus a number, happens before a multiplication is to put parentheses around it. So, we'll start with 5 times, now the quantity. We would not normally add before we multiply, but in this case we should to retain the meaning of the English. So, open up a set of parentheses, put 4 plus an unknown number, in this case f, close the parentheses, and that expression matches what the English says. We have 5 times a quantity. What quantity? 4 plus an unknown number. Here's an example like one you'd see as part of a word problem. An animal can run 60 feet in 1 second at top speed. Write an expression for the distance this animal can run at top speed in a given amount of time. I like to reason from patterns when doing this. First of all, the animal's top speed is 60 feet per second. In 1 second, then, at top speed, the animal can run 60 feet. If it maintains its speed for 2 seconds, it'll travel 120 feet. And if it maintains that speed through 3 seconds, it'll travel 180 feet. How are we getting these numbers? Well, I got the numbers originally by adding 60 each time, but repeated addition is something that we usually model using multiplication. Looking at this, I see that 60 times 1 is 60, 60 times 2 is 120, 60 times 3 is 180. I believe that pattern's going to continue. So, I'm going to model this as a multiplication. Now, they didn't give us an actual amount of time. They talked about a given amount of time, but they did not name it. So we'll have to give it a name. We'll give it a letter. We'll call it T. So, the expression for the amount of time that this animal can run in T seconds is 60T. Another example, bagels cost $1.50 each. What is the cost of a given number of bagels? Well, let's build a pattern. We know that one bagel costs $1.50. 2 bagels will cost $1.50 twice, or $3. 3 bagels will cost $1.50 3 times, or $4.50. This is another multiplication model like the one we just used. The price of a given number of bagels, even though they didn't actually give us a value, would be the price times the number of bagels. Let's use B for the number of bagels. The cost of a given number of bagels, then, is $1.50 times B. Our final example, how many hours are in a given number of minutes? Well, we have a relationship between minutes and hours. There are 60 minutes in 1 hour. But what's the relationship if we reverse it? How many hours are in 1 minute? Well, to take 60 minutes and turn it into 1 minute would require us to divide by 60. We should do the same thing to both sides then. 60 minutes divided by 60 is 1 minute. The reason we do the same thing to both sides is that we want to retain equality. If we don't do the same thing to both sides, we won't be able to use the equal symbol again, because there's no way the two things could be equal if we don't treat them equally. Dividing the right side by 60, we end up with 1/60th of an hour. Let's see if that makes sense. If we have 1 minute, that's supposed to be 1/60th of an hour. What if we have 2 minutes? Well, that would be 2/60ths, according to this way of thinking, or 1/30th of an hour. If we had 3 minutes, 3 minutes would become 3/60ths of an hour, which would reduce to 1/20th. That does make sense to me, because you could have 3 minutes 19 more times. You put it all together, you've got an hour. I'm inclined to accept this as my answer, based on this methodology. I think this example fits in the set because it's so easy to find multiplication examples, and yet there are many math problems that you'll have to do, not only in math class, but in science class, where you have to convert one unit to a related unit using a conversion factor. This sort of thing will come up frequently in your work this year. You need to know how to do it and how to discover these relationships. I hope this ShowMe has helped you understand the relationship between phrases in English and expressions in math. Remember that phrases in English aren't sentences or clauses, and they don't translate into sentences in math. You're not going to see equal signs or inequality symbols in your results for these. You're just going to see representations of numbers using variables, numerals,